Yes, this one structural cut really does destroy container homes. But the real problem is that most of the reinforcements you see online actually make the failure worse over time. They are a dangerous illusion of security. If you search for how to cut an opening in a container, you will see the same process repeated endlessly. A builder takes an angle grinder, cuts a large hole for a window or door, and then to fix the opening, they weld in a simple square frame of steel tubing. It looks clean, it feels solid to the touch. The builder believes they have added back the strength they removed. This seems correct, logical, and responsible, but it is based on a fundamental misunderstanding of how the structure actually works, and it ignores the most critical principle of engineering. To understand the error, you must understand the container itself. It is a semi-monocoque structure. The strength is not concentrated in beams and posts, like a traditional house. The strength is distributed across the entire skin. The corrugated steel walls are the primary load-bearing system. Every single fold in that steel is an engineered element designed to carry and transfer forces along a continuous load path. When you cut through that corrugated panel, you are not just cutting a wall, you are removing a massive amount of distributed stiffness. You have dynamited a section of the structural highway. The popular solution of welding in a simple frame is an attempt to patch the hole, but it does not rebuild the highway. It addresses a symptom, the hole, but ignores the real disease, the broken load path. This brings us to the core engineering concept that almost everyone gets wrong: the difference between strength and stiffness. The thin steel tube frame that is welded in is strong. It can resist being crushed, but it is not stiff. It does not have the ability to resist bending and deflection to the same degree as the massive, corrugated panel it just replaced. By welding this strong but not stiff frame into the wall, you create a structural imbalance. You now have extremely rigid points, the corners of your new frame, surrounded by new weak zones where the wall will now flex and deform. The failure is not immediate. It is a slow, progressive deformation. Under real-world loads from wind, snow, and thermal expansion, the structure will begin to move. The roof rail above the cut will sag, the floor will deflect, and over months or years the symptoms will appear. Doors that jam, windows that crack, and seals that break. The common reinforcement didn't prevent the failure, it simply delayed it and made it harder to see. The professional solution is not about patching, it's about rebuilding. The central rule of structural modification is this: the stiffness you add must be equal to or greater than the stiffness you removed. An engineer does not guess. They calculate the stiffness of the corrugated panel being removed based on its thickness, the depth of the corrugations, and the properties of the steel. Then they design a new system that provides an equivalent or superior resistance to deflection. This often involves much heavier steel tubing, I-beams, or even integrated truss systems. The goal is not just to frame the hole. The goal is to create a new, continuous, and unbroken load path that captures the forces from the compromised structure, channels them safely around the opening, and reintroduces them back into the main frame. It is a structural bypass, not a simple patch. Container homes don't fail because people cut steel. They fail because they cut engineering.